You have to calculate the mean value. So how do you calculate the mean value? Let's say 5, 5.1, 5.2, 5.3, 5.4, all these are given. How will you calculate it? You add all of it and divide it by the number of the values that are present. If it is, let's say when we add it, it's 26. So 26 divided by 5.2. So when you take the mean, that is represented by an x bar. This is known as its mean value. Okay, this value that we get, this is known as mean value. That is mean absolute error over here. Now, mean absolute error, how do you calculate then? Once your mean value has been found, let's say 5.2 is the mean value, you subtract it from each of the values, whatever values, whatever readings you had. So you subtract this from each of them, and then you get all these values. Then what you do, you calculate the mean absolute error. How do you calculate the mean absolute error? Whatever individual errors you have got, you calculate their average as well. Okay, just one more point here. I think you couldn't write it in the last class, no?
Yeah.
Okay, just one more point here, then you can write it. How do we represent the final answer then? You have mean absolute error also, you've calculated the mean also. Then how would I say what's my error in the calculation? If I have so many readings, what's my final calculation? So the presentation is actually, see, you take the mean value plus minus whatever is this mean absolute error. Mean absolute error. Okay, let's say this is mean, we represented it as x bar plus minus and delta x bar. That is for mean absolute error. So this is how you represent. Let's take here what we were getting. What were we getting? This was 0.10 minus 0.1 minus 0.2. Okay. See, for the mean absolute error, it's better if you take the modulus, okay? Because whenever you will have the values more or less, most of the times this will come negative. So you take the modulus. If you take the modulus over here, you'll get 0.2, 0.2, 0.1, 0.1. So that makes it 0.8, 4, 5, 6. This makes it 0.6. So here you will have 0.4, 0.5, 0.6. Yes, 0.6 divided by how many number? 5 is there. So 0.6 divided by 5 will be our mean absolute error. Okay, so delta x bar, if you have to calculate it in here, just take the modulus of all the values. Modulus means if it is negative, you are going to take it as without the signs. Okay, mod means that. So 1 was what? 1.0, 0.10. Okay. So this is 0.2 plus 0.1 plus 0.0 plus 0.1 plus 0.2. Okay, and divided by 5. That makes it, this is 456.6 divided by 5. So that is 0.12.
It was minus 0.1 with the negatives were there.
Yes, I told you just now, Maha, that you take the modulus. When you're adding, you take the modulus of all the values. Okay.
Oh, okay.
Okay, this is what I was saying. You take the modulus because most of the times it will then be 0. You'll not be able to calculate the mean absolute value. You take the modulus, we get this. Now, finally, how will I represent my answer? Whatever were my readings, suppose this were my readings. Now, what do I say? What's the final value to my answer? So I'll say mean value. Look, what was the mean value that I got? Mean value was this when I added them and divided them by 5. That was 5.2. I'm going to write this as 5.2 plus minus, what am I getting? 0.12, this much. And whatever it is, if it is position, let's say this centimeter, let's say this is length only. I think we were discussing the length of a pen something, yes. So this much centimeter is the error to all these values. This is how we represent and write our final answer. Got it?
Okay.
Now, Ma, you copy down this. Till here, I think you have copied from this. Right. Okay, please write it.
So I got disconnected.
Yes, Ma. Is your network fine now? Are you able to see the screen?
Yeah.
Oh,
I'm done. I'm done.
here, when you're writing, just put the modulus sign here only, so that you know when you add them, you have to take the mod only.
Okay. Yeah. Done, ma'am.
Okay. Now this is how we talk about the mean error, mean absolute error, and its representation. There's one more important part, that is the fractional error. Fractional error. Now, fractional error is what? It's the same thing only, but it's just a way to represent and write. Basically, fractional error is equal to whatever is your absolute mean error divided by the mean error. Means these two things getting divided. Delta x bar getting divided by x. And sometimes it is asked to write the percentage error. So percentage error basically means that whatever is the fractional error, you multiply it to 100. That is delta x bar divided by x bar into 100. That's it. Now, how will you represent your final answer? You will represent whatever is your mean value you already had, the mean value that you had, plus minus the percentage. Okay, directly. Representation, representation, because you will get the questions in this form only. So this will be whatever is the mean error plus minus whatever is the error percentage instead of the mean value. If you have the percentage given, if only absolute mean error is given, you're going to add and subtract that only. Let's say, let's take a small example. Yeah. See, let's take a small example where, let's say we have a length, okay? A rod is there whose length we are calculating. So example, let's say a rod is there whose length that we've calculated is 6 plus minus 0.6 centimeter. Okay, this is it. Now I want to write it in terms of the fractional error and the percentage error. This is after the whole calculation, mean calculation, absolute mean error and everything. So when we'll calculate the fractional error will be delta x bar divided by x bar. So delta x bar here is 0.6 divided by 6, that is 0.1. This is the fractional error. Now, if we are talking about the percentage error, what we have to do? This whole thing, delta x bar by x bar into 100 simply. So this becomes 0.1 multiplied to 100, that is 10%. Now, how will I represent this error? This was in terms of x bar and delta x bar. Now I want to represent it in terms of the percentage error. So finally, so bar was 6, x bar will come 6 plus minus. What's the percentage error? 10%. This is the answer. So two methods are there to represent the error. And percentage also, and percentage will be used when I'll tell you, like after this only I'll tell you the properties that are there. Addition, subtraction, multiplication, and division. And your many previous year questions of NEET have come from the division part that I'll tell you. Okay. Addition also, these questions from error analysis come. this part, then let me start with the properties. Okay. Is that clear till here, Maha?
Yeah.
Okay, then right.
Done. I'm done.
Okay, just write down this error as well. Then we have the properties of error. This is also known as, sometimes you will find it as propagation of error. Okay, this is propagation of error. Properties of error or propagation of error. Now, first two very easy. You have addition and subtraction. How do we add? How do we subtract? So first, let me talk about addition. See, in addition, just remember 2 points. Mean value will be added and the error will also be added. Error will be added too. For example, if I say, let's say we have two spheres. This is one sphere and one more sphere we have. Let's say this is one sphere, okay? This is the sphere A, this is the sphere B. So when this was calculated, let's say 2 centimeter cube plus minus 0.02, or in fact, I'll write it together. 2 plus minus 0.02 centimeter cube was the error in the volume. Error and the mean value means around 2 centimeter cube was the volume of it, with 0.02 error. Plus minus means it can be 2.02, or it can be less than it, 1.08 as well. Okay, so this is what is meant by when you write 2 plus minus 0.02. Similarly, let's say this is volume of A, volume of B. This is 4 plus minus 0.04 centimeter cube. Now, when I'm talking about their errors, I want to add. Let's say I want to take VA plus VB. So we have to add the mean values. Mean value means 2 plus 4. That becomes 6. So this is the mean value. And when you are adding the errors, adding errors means you are adding the, what is this?
Errors.
How do we get this? What is this called?
That's the
Mean
error
absolute.
part, right?
Mean absolute.
Okay.
Okay. Because we've already calculated it. It's the error part. It's the mean absolute error. Okay. So this will also be added. So when you add the mean absolute error, delta V bar that we'll get will be 0.02 plus 0.04, which is equal to 0.06. So finally, we can say VA plus VB is equal to 6 plus minus 0.06 centimeter cube. That is the whole conclusion from addition. But if I talk about subtraction, there's just a small change. This was addition. Now coming to subtraction. In subtraction of errors, here also you need to remember 2 points. Since you're subtracting, so mean values will be subtracted and you have to take the modulus. Okay. In the sense, whatever is greater, subtract greater minus lesser. Mean values will be subtracted. And here you're going to take greater minus lesser value. Okay, this is how you have to subtract. Now, second point is that error will still be added. Whatever is the mean absolute error, this will still be added. Here, you're not going to subtract the errors that you're getting. Okay, the
Okay.
way the errors were getting added in case of addition, here also the errors will be added. So, errors will be added. Let's say if I take the same example, if I continue with the same example here, now I have to get VA minus VB, or just the difference between them. So for the mean value of the volume, I'll get, see, one was 0.4, one was 4, and other is 2. So this becomes 4 minus 2. That is true. And when I take delta V bar, this will still be 0.04 plus 0.02. That is equal to 0.06. So when I write my final answer, VA minus VB, this will be 2 plus minus 0.06 centimeter cube. So this is what the difference will come in their values. Adding will give 6 here. Subtracting will give 2 here, but errors will always be added. Got it?
Yeah.
Okay. Write it down. Write it from here.
I'm done. I'm done. Done. Done.
Okay. See, now the third property is third and fourth very similar, like your addition and subtraction were very similar here. Now your division and multiplication will also be very similar. So first, talking about multiplication. Now see here, we don't just multiply as it seems like, okay, if we've added the mean values, so here also we should just multiply the mean values and let's see what we'll be doing about the absolute errors. No, this way it won't go. See, for multiplication, what will be done? Let's say you have anything, let's say y is equal to x into z, some random thing it is, okay? Now, when you are multiplying them, see, you have to take the mean absolute error value of y, delta y, divided by its true value, y, is equal to x is there, delta x divided by x plus delta z divided by z. This is how you write. For example, let's take area. Area is equal to length into breadth, length into breadth. So A is equal to L into B. See how we'll write. These values will be given to you in the exam. I'll show you questions also, how the questions have come, and a lot of questions have come from this fractional part. Delta A divided by A is equal to delta L divided by L plus, you'll not multiply, delta B divided by B. Okay? Delta A divided by delta, you know, it's the mean absolute error. So you won't have to calculate it. Its value will be given. Probably you will be given the percentages. See, this thing, if I divide it, multiply it with 100, that will give me the percentage error. This is the fractional error. So fractional errors value will be given to you, and the basics formula you already know. Okay, so when you have some random values, this is how you have to solve. Or one more example, let's take mass is equal to density into volume. So we say M is equal to rho into V. So we'll write delta M divided by M is equal to. Here this becomes delta rho divided by rho. Now into you don't multiply. You write plus delta V divided by V. And many numericals also from other chapters get solved through this technique. If you know the error, if you know their percentages, sometimes in the questions we have no percentage changes, this that, so especially in fluids and all. But yes, you cannot use that in your school exams because you have to follow the procedure in the school exam for whatever topic you're studying. Okay, you cannot use this, but in the NEET paper it is very helpful. This technique is very helpful when you have the percentages given. Especially first understand this, then you'll be able to understand the rest. Now multiplication is this. Now, if I talk about division, division is no different than this. Even if it is division, you just have to apply. Fourth point, let's say this is division. In division, let's say some values are there. Y is equal to x divided by z. So same thing, here delta y by y will come is equal to x is there. Again, delta x by x. It is getting divided by z. Still, you will write plus delta z by z. Like this, you're going to add all the values. Okay, whatever is it. Got it? Now, if it combines, let's say if I combine multiplication and division, because you won't just have multiplication separately or division separately. It is, this is fifth one. If it is multiplication and division, means you have so many formula where you have all the things together, right? If we studied about, let's say, force is mass into velocity divided by time, momentum divided by time, the rate of change of momentum. We did it in laws of motion chapter. So see, now if I have to write this in terms of the error analysis, I'll write it as delta F by F is equal to. Now mass is there, so delta M by M plus this velocity is there, so delta V divided by V. Now these two are getting multiplied, so we use this. Okay. Now this is getting divided, so plus delta T divided by T, like this. So in division also it was the same, in multiplication also it was the same. Okay.
Yeah.
When you're combining it with, it will occur like this. Now, if the powers are there, that is the most important part. Do one thing, write it till here, then we'll discuss the numericals also, and if the powers are there, that will change
Okay.
values. Okay, start writing from here.
I'm done. 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 Done.
Okay, one more property that I was mentioning about the powers. Okay, whenever you have powers, because this is the most important after all. All of the properties that we studied, they are important. From addition, there was once question that came. Resistors were values of resistances were given, and in series, the net resistance was asked. So that you have in class 12th, the portion of resistance and current and all. So you don't have it in class 11th. But from your lower classes, if you remember series and parallel connection, सुना है पहले? So
Yeah.
there, when you have series
Just a bit.
connection at them. Yes, yes. A little bit of series and parallel you must have heard. 1 by R1, 1 by R2, like this. So in series, we just add the resistors. So in resistors are also devices. So there was once a question that came in your NEET paper. One value of resistance was given. 6 plus minus 0.03 ohm, like this, and one more resistor was given, and series addition was asked. So you had to add it. Okay, like this the questions are there. We'll practice question. This won't be completed in just today's class. Next class we need for its practice. That will be the last class for this at least. Yes, so when I'm talking about the powers now, powers, they get multiplied to the fractional term. Okay, let's say I have y is equal to x z divided by, okay, x square z to the power 3 z cube and a to the power 4. I have this. Okay, now when we write delta y divided by y is equal to, we have delta x divided by x. That's what we studied. Now the power is 2. So you multiply it with 2 plus z. What did I tell you? That whenever you have z, so you take delta z divided by z. Power is 3. You multiply it with 3 plus 4 delta A divided by. This is most commonly used in the paper, and the questions are often asked from this. Let's say P is equal to m cube n to the power square divided by q. Okay, let's take we have this. So delta P divided by P is equal to 3 delta m by m plus 2 delta n by n, and no power of q is there. So only one power is there. So we take delta q by q. Okay, that's how we use powers. So now if I multiply 100 with on both the sides, or do one thing, you write this down, then let me come to the percentage formula. Okay, just write down the sixth point as well.
Done. Done.
Okay, Maha, one more thing. See, if in this I want to write it in terms of the fractional power, okay, I want to write it in terms of the percentage of error. What's the percentage of error in all of these things? So what I do, let's say I have y is equal to some a to the power m, some b to the power n, and let's say some c to the power q. This is the general form. So when I'll be writing it in terms of the percentages, I'll write it how delta y by y is equal to, tell me, dictate, Maha, how should I write?
M into delta A by A, so delta A by A,
Yes,
and then
right. Plus,
plus N into delta B by B,
correct.
plus Q into delta C by C.
Yes, right. Now see here, if I do one thing, Maha, on both the sides, like here, this term, I multiply it to 100, and this whole term, if I multiply it to 100, look, what will I actually get? Delta y by y into 100. Wasn't it? See, delta y by y is the fractional error. Okay,
Yeah,
remember? And if we multiply it by 100, what do we get?
error percentage.
Yes. So percentage error in y is equal to, now see, m times delta a by a into 100. 100 will this 100 will be technically multiplied inside also within the bracket. So it will be m times the percentage error in a plus n times the percentage error in b plus q times the percentage error in C, like this. So this also comes directly in the exam. I'll show you one question, how a question directly came in the exam. And this same question as it is, without even the values getting changed, it repeated itself in the 2019's paper as it is. Now look, this is a question from 2013, which originally came. So quite easy to solve for you. It is in an experiment. Four quantities are there, A, B, C, D. They are measured with percentage error. Now directly you have the percentage, no fractional and all required. So for A, it's given as 1%, B is given as 2%, C is given as 3%, and D is given as 4%. And the quantity, how it is calculated, the percentage value is given, the formula is given. So Maha, tell me, how should I write delta P and all? Delta P by P, how should I write?
Equals 3 into delta A by A
Yes,
plus 2 delta B by B
yes.
plus delta C by C plus delta D by D.
Very good. Okay. Now see, when you have the percentages given, you can skip this step. Okay. This is for the questions that is beneficial, because see, right now you should just be able to see what are the values. Look, now just write it in terms of the percent. Once this is written, no need to multiply 100 with all of it, and I'll just do one thing. This will be the percentage of P into 3 times the percentage of A. Now with the percentage of A is given as 1 plus 2 times percentage of B, which is given as 2, plus the percentage of C. In fact, I'll just add percent at the last, plus the percent of D. So this makes it 3 plus 4 plus 3 plus 4. That is 14. So 14% is the answer. Got it?
Yeah.
Okay. So these kinds of questions I'll share with you today. Just do them. 2 to 3 I'll share with you. Just attempted calculations
Okay.
will be very easy. In 5 minutes, you'll be able to do most of the questions. Maha, till where did you write? Did you write this power part?
Yeah.
Okay, then please write it from here.
Done. Done. Done, ma'am.